In this video, we're going to talk about estimators. So what's an estimator? That's a great question. So an estimator, this is simply a statistic that is used to infer a population parameter. Right? So we are looking at this value that we are going to be able to use to say something about what's true about the entire population. So what types of estimators might we get? Well, we could either get estimators that are unbiased or estimators that are biased. And so when we see an unbiased estimator, that is saying that the statistic targets the value of the population parameter in the sense that if we were to take a sampling distribution of the statistic, right, so it doesn't matter whether that statistic is a mean or a variance or a range or a proportion, if the mean of the sampling distribution is equal to the mean of the corresponding parameter, then it would be unbiased. And so what this kind of means is if this is the true population parameter, if we were to take all of the values that could show up, the mean of all of those different things that could show up, they would be well balanced around here. So we would have the same number on either side. They would be kind of properly balanced so that the mean of all those things that could show up is actually the mean of the individuals. So what are some unbiased estimators that we have? Well, the mean. Sample means, those are unbiased. So if you were to consider the sample mean, the mean of the entire population, mu, that is equal to the mean of all of the sample means. Right? So means, those are unbiased. A variance, sample variance, that is unbiased. Sample proportions, so proportions, that is unbiased, so p hat. The mean of the proportions is equal to the mean of the proportion of the entire population should be equal to the mean of all of the sample proportions that we could get. We have some biased estimators. So biased estimators would include a median. So when you look at all of the medians of all of the different samples you could get, the mean of those medians, it is going to regularly look like it's not targeting the true median. The mean of all of the medians won't be the median. You have the range. The range is biased. The mean of all of the ranges is not equal to the mean of the range. It's not the same value as the range. And finally, standard deviation. This is also biased. I will make a quick note that if our size of the so if our size of the sample is relatively large, then the bias is less. So as n gets bigger, the sample size that we're looking at, as that gets bigger, the amount of bias in here gets smaller. All right, so let's take a look at the range. So we're going to come up with a sampling distribution for the range. Here, our range is, remember we take the maximum minus the minimum, so 1 minus 1 is 0. The next one has a range of 1, and then a range of 2, and then a range of 1, and 1, and a range of 2, a range of 2 again, and then a range of 1, and back to 2, and back to 1, and 1, 2. So here what I'm doing, I know I'm just reading off random numbers. I'm taking the largest value in these 3. I'm subtracting from it the smallest value. Our next value is 0. And then our next range is 1. Then 2. And then 1. 1 again. And then 2. And 2. And 2. And 2. And 1. And 1 and 2. And 1 and finally 0. So those are all of the ranges that show up. Let's look at the sampling distribution of the ranges. So we had a range of 0, 1, 2, but not 3. 0, 1s, and 2s, those are the values that showed up. 0 showed up 1, 2, 3 times. 3 out of the 27 different roles. The range 1, that showed up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times out of the 27. And a range of 2, hopefully that shows up 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that describes the probability of each of those ranges. We can find the mean range, the mean of all of those ranges based on this distribution. And so we would take 0, so the range 0 times its probability times 3 over 27, plus 1 times 13 over 27, plus 2 times 11 over 27. If we go through and do that, we get something like 35 over 27. So the mean of all of those ranges is something like 1.296. However, if we look at the original population, which is just we could get a 1, 2, or a 3, that range is actually 2. And so that range of 2 is not the same as the mean of all of the ranges that we get in the sampling distribution, because range is a biased estimator. The range for each one of these samples that we could get, it's never going to be larger than the range of the entire population. It might be equal to it if we happen to have the largest value and the smallest value, but if we are missing either one of those values, then our range in those samples are going to be smaller. So it's going to bias, it's going to underestimate the range if we look at the mean of all of the ranges. All right, in the next video, we're going to start taking a look at means of means. So we're going to focus specifically in on the sampling distribution of sampling means. All right, we will talk to you next time.